In lesson 1.3, we're talking about functions, and so we're going to start by talking about the domain and range of a function. The set input is called the domain of the function. The set of all images of the elements in the domain are called the range of the function. In other words, the domain is the set of x values, and the range is the set of y values. In this first example, we're stating whether the relation is a function, and if it is a function, state the range in the domain. So here, a is a function because each x value is different. So it would pass the vertical line test, and so we say that's a function. And then it wants to know what the domain and the range is. So your domain would be all of your x values, all the input values, and your range would be all your output values, so all the y values. So I've got 6 and 7. Looking at B, we have a relation, and I notice that -3 appears twice. So this input of -3 has different outputs, which means this is not a function. In order to be a function, each input has to have exactly one output, and this input of -3 has 2 outputs. If we look at C, this is just another way of looking at a relation. This is called a map, and so we can see 2 has an arrow to 8, so if you input 2, you get an output of 8. 3, when you input 3, you get 7 or 8, and when you plug in 4, you get 6. So because 3 has 2 different outputs, this is not a function. Each input can only have exactly one output. So looking at functions, when we're talking about a domain, we strictly are looking at the inputs. So domain are the x values, or the input values of a function that outputs a range or y values. So when we look at the input, or the x, or the domain, we need to find the values that are omitted in the domain, or the inputs. So let's look at this simple function here, 5 over x. We can plug in an infinite number of numbers into x, except we cannot plug in 0, because when we plug in 0 for x, we get 0 in the bottom of a fraction, so 0 in the denominator creates an undefined number. Therefore, 0 cannot be in the domain. So we're going to have to restrict the domain for that function. And so we would say x cannot equal 0. Well, so let's look at these functions. I can plug anything I want into this function. I'm not going to get 0 in a denominator. I'm not getting a negative under a square root, so there are no restrictions. And if there are no restrictions, then the domain means all x values work. So we can write that as -infinity to infinity. All x values from -infinity to positive infinity will work in this function. So my restrictions are what does not work. My domain is what does work. So if I look here, I can't have 0 in the bottom. I can't let the bottom equal 0. So what will make 0 in the bottom? Well, if I add 2 to the other side, I see that x cannot be 2. So that's my restriction. X cannot be 2. Well, how do I write then what does work? If 2 doesn't work, then what does work? Well, everything smaller than 2 would work. So -infinity up to 2 works. And then everything bigger than 2 would work. But 2 itself does not work. So this is how we write it. Everything smaller than 2 works, and everything bigger than 2 works. But I put parentheses on the 2. Remember, parentheses means it does not work or is not included. If I put brackets on the 2, then I would be saying that 2 works. But parentheses tells me it doesn't. Let's look at this fraction. I can't let the bottom equal 0. So, well, what if I solve and figure out what would make the bottom equal 0? So subtract 3, take your square root, and then I get plus or minus I radical 3. Well, this is an imaginary number. So that means all real numbers work. So there are no restrictions. No restrictions. And if there's no restrictions, our domain, just like in A, is -infinity to infinity, which means all x values work in this function. All right, let's look at D. We can either factor this. This is a difference of two squares, so we could write it like this. Or you can set it equal to 0, like we did in part C, and add 4 and take the square root, but you got to remember to do your plus or minus when you do that. But either way you solve it, we're going to see that x equals 2, x equals negative 2. So those are our restrictions. That's what x cannot be. X cannot be plus or minus 2, positive or negative 2. Because if I plug in positive or negative 2, I will get 0 in the denominator, which will give me an undefined answer. So what does work? What's my domain going to be? Well, let's look at negative 2. Everything smaller than negative 2 would work, up to negative 2. So I'll write it like that. Then I've got all the values between negative 2 and 2. So all the values between negative 2 and 2 work. And then I've got all the values larger than positive 2. So 2 restrictions gives me 3 pieces to my domain. I've got everything smaller than negative 2, everything between negative 2 and 2, and everything larger than 2. Then let's look at e. E, we've got a square root function, and we can't let there be a negative in the square root because that creates an imaginary number. So for this one, to find your restriction in your domain, it's a little confusing. So restrictions, we want to figure out what does not work. Domain, we want to figure out what does work. So let's talk about what would not work. What would not work is if this was less than 0. So let's set this less than 0. And whatever x value we get, that's going to be the restriction. So if I subtract 4 to the other side, I get that. And then if I divide by negative 3, remember when you divide by a negative, the inequality flips around. So we've got greater than. Negatives cancel, so we get 4/3. So this is my restriction. X cannot be greater than 4/3. That's what x cannot be. So what can x be? So then the domain, so not work, and what works is the opposite. So x can be greater than or opposite, less than or equal to 4/3. So everything smaller than or equal to 4/3 works, which we would say negative infinity up to 4/3 works. And we always put parentheses on infinity. And since we have an equal to symbol on 4/3, we put a bracket on it.